What's up, everyone? Today we're going to be looking at section 5.2, and this starts us being able to solve a quadratic equation. There's several different methods that we can use to do this. Graphing is the method I always like to start with because it gives us a nice conceptual understanding of what it means to be a solution to a quadratic equation. Okay, so I want to pose a question. What if we replace y in a quadratic function with 0? How does that change the problem? Well, when it's y equals ax squared plus bx plus c, our solution would represent an infinite amount of ordered pairs or points on the parabola that make the equation true, okay? But if we take the y and we replace it with 0, we are now looking for the values of x in this function that will result in a y value specifically of 0, okay? So these would be the x-intercepts of the graph. All right, and if you look at the parabola on your screen here, this particular equation would end up having two solutions to it, okay? So these 2 points, let's call them x sub 1, 0, and then x sub 2, 0. These are the only points on the parabola whose y coordinates are 0, okay? Now, these can be referred to as x-intercepts, but there's also some other names that we could call them. We could refer to them as roots or zeros or solutions, okay? All of these words are synonymous with one another, all right? So moving forward, use the graph of each quadratic function to find its roots or its x-intercepts, okay? So where are we crossing the x-axis at, right? The parabola on the top left has 2 roots. They would be at x equals 2, or I'm sorry, negative 2, and positive 3. And we're simply looking for the x values, okay? Don't write them as ordered pairs, all right? The next graph on the top right, it only is touching the x-axis in one spot right there. So it has one root at x equals 3, okay? The graph in the bottom left here that's in green doesn't touch the x-axis at all. So we're going to say that this has no real roots, meaning there are no real numbers that you could plug in for x that would result in a y value of 0 for the associated function, okay? And then the last parabola in blue here, it has two roots or 2 solutions. And what I want you to notice is that from the graph, we can't tell specifically what the coordinates or what the x values are of each of those points. We can only estimate, okay? So I'm going to say what 2 consecutive integers each one of these falls between, okay? So the root on the left-hand side, it's between values of -4 and -3. And I'm going to write this as a compound inequality, okay? My second root over on the right-hand side is between +1 and +2. Okay, so that's the best we can do just by looking at the graph. We can't be sure of exact roots here, okay? All right, moving forward into example 2. So this time we are given an equation to solve, and we have to do it by graphing, okay? So notice there's only one variable here. This is my indication that I'm looking for the roots or the x-intercepts of the associated parabola, okay? So the first thing I'm going to do is get this set equal to 0, and I would do that by simply subtracting 3 from both sides. So that would give me x squared minus x minus 6 equals 0, okay? Now, for a moment, I'm going to treat this like a function. So now I'm going to graph f f of x equals x squared minus x minus 6. And I would graph that the same way we did in all of our examples from the last section, okay? So I'd begin with x equals negative b over 2a. That's the negative of negative 1 over 2 times 1. So that'll give me 1/2. All right. And then I'm going to, how about I show the work on this since that's a fraction? So I'll find f of 1/2 to get me the y coordinate of the vertex. 1/2 squared minus 1/2 minus 6. So that's 1/4 minus 1/2 minus 6. Need some common denominators here. So 1/2 I'll change to 2/4. Negative 6 I'll change to negative 24/4. And then in the end, this is going to simplify to negative 25/4. Okay, so the vertex for my associated parabola is 1/2 negative 25/4. Okay. All right, so now I'm just going to make a table here. And I'm going to put that point in the middle of the table. And then I'm going to pick a couple other values for x on either side of 1/2. So I'm going to start with 0, negative 1, as well as 1 and 2. Okay. So f of negative 1 ends up being negative 4. F of 0 is negative 6. F of 1 is negative 6. And f of 2 is negative 4. All right, so we plot all of those points. Kind of have to go off the graph just a little bit here to get that vertex on there. All right, now my issue is with the 5 points that I have right now, I'm not going to be able to directly see where I'm crossing the x-axis at yet, okay? So this is an indication that I should probably plug in a couple more values in for x, okay? So I'm going to add in to my table an x value of negative 2, and then let me move this out of the way. I'll also add in an x value of positive 3. And both of those, when you evaluate the function, they should yield 0. Okay, and that is exactly what I'm looking for. I'm looking for when this parabola crosses the x-axis. Okay, so these x values of negative 2 and positive 3 are in fact my solutions or my roots for this equation. Okay, and I'm going to write them as follows. Just say solutions or roots or zeros are x equals negative 2 and positive 3. Okay. All right, example 3. Solve 0 is equal to 2x squared plus 4x minus 3 by graphing. And I've got some extra directions in here. It says if exact solutions cannot be found, write an inequality to state the consecutive integers between which the solutions lie. And basically all that statement is saying, if we go back and look at example 1, it's basically wanting me to treat my solutions or write my solutions like we did here on this last example, or this last graph, okay? All right, so graph it's already set equal to 0, so I'm gonna graph f of x equals 2x squared plus 4x minus 3. Treat it like a function. X equals negative b over 2a to start, which would be negative 4 over 2 times 2, which is negative 1. Then I'll evaluate the function at negative 1. It'd be 2 minus 4 minus 3, which is -5. So my vertex is the point -1, -5. How about I plot that? Okay, then we'll make a table here. Put that vertex in the center. Pick two smaller values for x to start, two larger values. And when I plug -3 into the function, I end up with 3 for y. When I plug -2 in, I should end up with -3. F of 0 is -3 as well. F of 1 is 3. All right, so let's plot each one of those. All right, so there's the parabola, and you can see that my roots are here and here. And again, I can't be certain what those exact values are for those. So this is where these directions come into play. I'm going to write an inequality to state the consecutive integers between which each of these lie. So the root that's on the left is between the x values of -3 and -2. And the root that's on the right is between 0 and 1. And there you have it. All right, we're going to stop here. That's all for this video.